So we have a beam, and our beam contains very, I would say, simple wizard. And in this wizard you can generate some basic data, and then you can adapt the data. So for example, here we have cast in situ concrete beam, and I selected reinforced. We can also post-tension composite and others. In spite of the fact that I will be analyzing the beam in the corner above the corner window, I decided to use this wizard for continuous beam, so that the program will generate two spans. I will show you later. So when I press next, I can go and select either beam in 2D or beam in 3D, which is my case, polygonal beam, and spans will be 3 meters and 3 meters. So I use 3 space 3. In fact, I tested this example before my presentation. That's why all the data is already in the wizard, because the program remembers the data. Then I can check the design code, EN or SIA, or some annex, design working life, and cross section. If I select the cross section, then we have possibility of several possibilities. I will show in the other example. Now I will use this rectangular beam, and my depth of the beam will be, I estimate that it is 300, and because it is above the wall, which is thick 45 centimeters, I select 45 centimeters width. So that's it. Material I already selected. I want the program to generate cell weight according to cross section, and my permanent load is 3 kilonewtons per meter, and my variable load is 5 kilonewtons per meter. I want the program to generate critical load patterns in different spans. Then I press finish, and I have the beam. Now you see that it is the straight beam, which we did not want to make, but we have two spans, one span and second span. What I want to do, I do not want to, I can change the data here in the data window, code, type of beam, working life and other things. I can change the cross section, which I do not want, materials, members. Here I want to make some changes. And what will be the changes? First of all, I want to generate this beam, the real shape of the beam. So I enter 3 meters delta y in plan, and here will be 0. That's why I get this beam above the corner. And I can show you top view. This is top view of the beam. Okay. Now I have to adapt the supports, and we see here those are the global axis, X, Y, Z. So RZ will not be there, but it will be restrained in vertical bending, in vertical flexure. Also rotation, torsional rotation will be restricted, and all these X, Y, and Z displacements. Here I do not want to have any support, and I want to have the same supports in the other node, in node 3. So that's it. My input is adapted, and now I can see, of course I could use the haunches and various load cases. I will not be going to change anything because the program generated what I needed, but I want to show you. This is cell weight defined according to cross section. This is permanent load, this is life load, this is life load in one span, and this is life load in second span. This is what I explained, that we have critical patterns. Okay, Here we have settings for permanent load groups and here for variable load groups. Okay, I keep all these coefficients as they are. I can add point forces, point moments, uniform loads, line load settlements, and now I go to combinations. Here we have not the combinations, but we have in fact the, I would say, combination rules. Combination rules, or the order of the user for the program how to generate the combination. You see that all my load cases have the factor 1. If we have factor 1, means that we tell to program that the program should use these load cases in the combination so that it generates the extreme. The form of evaluation can be according to code 6.10, this is Eurocode, 6.10, 6.10 AB, envelope or linear, or we can use code envelope linear for SLS, characteristic, frequent, and quasi-permanent combination. Okay, so that's it. Now I can calculate it. I can see the reactions. I can see the deformations. I can see internal forces. For example, here we have My. Here we have a shear force. Here we have torsional moment. Mz will be 0. Okay, so My is here. We can select also. This is those are the envelopes from all ultimate limit state combinations, but we can use also all characteristic, all or for example only the effect of G, or this effect of life load loaded on first span only. So this is the possibility. I'm not going through all these settings. Now I go to concrete design. Concrete design, we should first select the exposure classes. So usually this is setting for bridges. So usually we have no risk of chlorides, and we have XC1 for carbonation. Here we can have all settings, what kind of checks we want to perform, what kind of redistribution we want to perform. By the way, I did not mention, but you see that now the program made the beam straight. In fact, now we do not display the beam, but so-called design member, which can be a representative member for a group of beams. Now if we have one beam only, then it is equivalent, or the same. But if you import it from Axis VM, for example, then we work with one design member which can represent, for example, 20 beams, which are produced in the same way. So those are basic settings here, and we can see the reinforcement. Now we entered this reinforcement. We work with straight beam because it is more convenient for the user. I want to draw these bending moments so that I can decide which zones I should use. So possibly because of bending moments I will have different zone, different reinforcement above the supports, and different here because we have different bending moments here. Probably I can move to 1.7 meters at this point, which I want to have in this deflection, and also here there should be, I think, 1.3, so that I move it here. So now I have it in inflection points, I can see, and I can use the reinforcement. Of course I tested it, so I know what reinforcement I should use, but I want to show you how the design would be performed. So I will make the reinforcement which would not be correct, which would not be satisfactory. My beam is 45 centimeters. For everybody knows that such a wide beam should have probably this double system of stirrups. So I would start with double system. I keep standard reinforcement. 4 bars, now diameter 10 in the top, 4 bars in the bottom, none on the side, and I want to use diameters of stirrups 8 centimeters. Let me to use distance 20 centimeters, which will not be satisfactory, but doesn't matter. And I just want to show you, if I say here, for example, 300, what happens. And oh, I wanted to have 200, sorry, 200. And the program would show you such stupid stirrup, and of course it would give you a warning in the check of the detailing. So it's better if you go back, if you see such reinforcement and you select, for example, 250, and then it is quite acceptable reinforcement. You might have noticed that I have 2 zones AA here and here. So once I reinforce one, then of course the other one is the same, so it takes the reinforcement from the previous. Now the second one, and I will keep it as it is, the same, because now I know that I will be changing this AA. So I can go through also this deflection. We can see that in XZ direction we have really no support. It is this one here, and in XY plane we have, of course, in a horizontal plane there is the other beam, so it makes like a support for the first one. So it should be okay as it is generated by the program. And I can see the redistribution and reduction of bending moments. You can see this reduction of bending moment here. There are some settings. You can get internal forces, intermediate results, and all other things. The program gives you some warning which you can read in here. In settings here, but I do not care now because I will change the reinforcement later. So let me to go to results. Now the beam calculates in several sections in each zone, both the ultimate limit state, serviceability limit state, but also the stiffnesses for the calculation of deflections, which is done in non-linear way. So, and you see brief summary of the results. You see that interaction was not satisfactory at all. It was above all limits, that's why it is 1000. But also capacity of the section here above the support is about 45% more than needed. So based on this, we can already, and here we have summary of results, we can already change the reinforcement, or we can go to section check, and here we have detailed description of the results and also what is not satisfactory and what are the code provisions for which it is not satisfactory. Similarly for deflection check. Or I can go to detailed now, and I open, in fact, I open this RCS program, this Optimal, and but I didn't show that's PT. I will go back to, sorry, I didn't show here in reinforcement. There are the zones, and I have several possibilities of division in the zone. So this is also something which we can if we increase the division, then we increase the precision, and of course it calculates a little bit longer, but we can evaluate the extremes along the length of each zone. Now we get only one extreme, which we have here. So let me to go to this detailed, and as I said, three sections are generated. One is above the support, and here we have for middle of the beam in BB zone, and again here this is AA zone. We can see the reinforcement, we can calculate it all, and we should get the same results. For example, if I select this one, I see this interaction is not sufficient. I can even see interaction, and it should give me some warning message what I should improve. Of course, shear check, so shear force is probably too big, and also because we have 145 here in capacity, we should add also, you see we are here, we should add also some longitudinal reinforcement. So if I go back, I can once more, sorry, I wanted to show also this. I already put 250 millimeters overlap here of this reinforcement. So my detailing did not appear because it is satisfactory. If I change it, if I change this, for example, I will have to change the stirrup. I will not do it. So what we know is that we should increase the amount of stirrups. So for example, here I will use 150 millimeters, the distance, 150. And also my reinforcement above the support is not satisfactory. So I think I could use, for example, 9 bars, because the moment is quite high. And I can go back, I refresh the data, and recalculate all the sections. Now only this one, BB, which we did not adapt, is not satisfactory, and we see that the detailing is not satisfactory here. So I go to detailing to see what is wrong, and I can see that maximal distance of stirrup is too big. It was 20 millimeters, 200 millimeters. So I will select it and I say 190 because it was only 3% more. 190. I go back to project data, calculate all, and I have all satisfactory. I can go back. I can even recalculate it now, including the deflections, because my reinforcement above the support changed. So now the deflections and everything is recalculated. And I can get the results along the length. You can see this is overall check. 98% is probably this one, interaction. And I can also see, for example, capacity, shear, torsion, this interaction, stress limitation, crack width, and everything. Here we have no crack probably. So that's what we can see on the screen. We can also change it into the deflection check and see the deflection, which can be linear, immediate, long-term, total, and limit is this one. Or I can keep only the total one and I get the maximum deflection. Stiffness, for example, immediate stiffness is like this. So here we have a little bit decreased stiffness because of the cracks. You can see long-term stiffness, immediate total. Immediate total is even worse. You can see now. And we can also see EAX and EIZ. Okay, so this is the stiffness. And what we can also see are the results for the redistribution, how we redistributed and reduced the moments. Table results for section check in each zone and deflection check. So that's it, and I think we can generate, of course, a report, either standard, which is shorter. You can, for example, we do not like these combinations, so we switch it off and we refresh and we get it. Or the detail report, which produces longer report.